Thank you very much, Matt. Now, I would like to introduce our keynote speaker, Dr. Steven Steinberg. Dr. Steinberg is LA County's Geospatial Information Officer, guiding the geospatial strategy for more than 10 million residents and 100,000 county employees across more than 35 departments. He currently serves as an adjunct professor in the Master of Science Geographic Information Science program at California State University, Long Beach. Dr. Steinberg is also actively involved in geospatial leadership positions and professional organizations. He calls himself a geospatial evangelist. And I can verify that he is truly passionate about the use of technology to solve real problems of people and their environment. So much so that he told me on his last vacation, he spoke at the conference. With that, I would like to hand it over to Dr. Steinberg.
Well, thank you so much, Yoko, and thank you to the well over 100 people, it appears, that are here today. I appreciate you all taking some time to join us. And I also want to acknowledge that video that you showed at the beginning. A number of the kinds of applications that are happening in Santa Clara County are similar to some that I'll mention here in LA County, and also talk a little bit about some of our emerging work in this area, since we're talking about the future. So let's go ahead and get started. And first off, just a little bit of an overview. I'm going to talk a little bit, for those who maybe aren't as familiar with LA County, a little bit about the county, where it fits in the geography of the world, a little bit about how we're using maps and GIS in government with a number of examples, and then a little about some of the ways we're collecting and using data in innovative ways going forward into the future, and then a little bit of wrap up. So that's kind of the agenda we'll go through over the next 35 minutes or so. So a little bit on LA County. If you're not familiar with LA County, we are the largest county in the country. We have a population as of 2021 of just over 10 million residents, which, if LA County on its own was a state, would put us around the 10th largest state in the country. So it's a big population, a big constituency to deal with and serve, and obviously a fairly large geography at over 4,000 square miles. Now, as you may know, county governments deal with the unincorporated portions of the land, meaning the areas that are not incorporated into cities. On this map that's on the screen, you can see everything that's colored in the tan color is the unincorporated county. Everything in white are 88 incorporated cities. That said, in addition to our responsibility to serve and manage all of the unincorporated portions of the county, we as a county provide contract services to over 50 of the 88 cities in the county. That may include emergency services like sheriff or fire protection. That sometimes is a number of other social services, or even GIS services in some cases that we contract with some of our cities who aren't doing that on their own. So suffice it to say, it's a large area with a lot of people and a lot of opportunities. As we look at just the structure of the county a little bit, and Yoko mentioned this in introduction, we have a lot of departments in the county, over 35, I think, as of most recent count. We're up to 37 or 38. They're always reorganizing things, creating new departments or splitting departments up as different needs arise. And of those departments, 14 of them actually have GIS staff positions embedded in their department. And then the rest of those departments are supported in GIS from our Enterprise GIS team that I'll mention on my next slide. In total, we have about, last count, 155 GIS positions across the county, across those 14 departments. We also support a whole slew of committees and special commissions, sanitation districts, water districts, school districts. You get the idea. We're big. Lots of employees, lots of infrastructure. just on our own, the county owns or leases office space or other facilities in over 4,000 buildings, over 63,000 acres of county parks and natural areas or gardens, such as the LA Botanical Garden. And we have a lot of budget. I actually was surprised when I looked up the numbers for this year because they went up by about $10 billion. Again, we're operating more or less at the level of a lot of states, or larger than many states across the country. So how do we do this from a geospatial perspective? Well, number one, we have a central enterprise GIS team that supports all of our core services GIS-wise for the county. So in doing that, we can avoid some duplication of efforts and leverage our resources more efficiently. So our enterprise GIS team manages a shared geospatial infrastructure, including hardware and software licensing, a lot of our core data sets that are used across multiple departments are managed and maintained through our enterprise systems and our enterprise program, and a lot of our day-to-day workflows, and I'll touch on some of these in a little bit. And you know, as a large county, of course, there's a lot of coordination between departments, but as is always true, there's a number of base data layers and databases that are useful across multiple applications, multiple departments. For example, almost everyone wants to know where roads are, or where parcels are, or how to look up an address, different topography or landscape cover features, and so on. Lots of departments and applications and analyses need that. One of the other things, and I'll touch on this in and out throughout the presentation, is especially during COVID over the last 2+ years, we found that GIS gave us a tremendous opportunity to take what would have traditionally been field-based operations, putting people out on the ground or in offices across the county, and been able to move those into desktop operations, doing a lot of work from the computer itself, whether that was working from home or working from, in some cases, office locations. And you can sort of get a sense of that in the two graphics on this page. And you saw this in the Santa Clara video as well. Aerial imagery, and I'll come back to this later in the presentation, provides a tremendous opportunity to visit sites virtually from the desktop by looking at high quality imagery that is linked to geospatial locations and databases. The figure on the upper right there, we did an analysis to understand drive time from every single of our 110,000 employees' locations to key locations in the county. And in the case of COVID, this was originally done to look at doing things like hoteling to let people drive to a nearer office location, a WeWork site or something like that pre-COVID. That all got thrown out and flipped on its head. And now we're using this to look at our carbon emission reduction, our fuel use reduction, and our time in commute reduction for our employees throughout the COVID pandemic as we've worked from home. How much time and reduced pollution and carbon emissions has there been? So we actually can monitor those kinds of analyses through. And ultimately, GIS is useful in a lot of ways to just optimize many of these operations. Now, it may be a bit of an obvious question, but why does government care about maps? Why does Santa Clara County, LA County, or any other local government agency work with maps and GIS so much? And again, you saw a lot of examples in the video around different kinds of service provision. We can understand something about what we offer to our citizens, where our facilities are, how people can find things that meet their needs and then navigate to those locations. There's been a lot obviously going on in the last couple of years around the US Census and then redistricting, and now next Tuesday voting in elections. How do we understand the distribution of populations and where we place things like voting precinct boundaries and vote centers, or where do we go to provide a new vaccination or COVID testing site during the pandemic? Of course, the real answer to this question is local governments need GIS data or parcel map data and assessors' offices to collect our money, our fee assessments. both property taxes, which is in most cases the primary source of funds that we operate on, but also other types of fees. So there's a lot of reasons governments use maps. Most of these should be pretty apparent to those of you who work in government or are aware of what we do in government. But I think more importantly, and this is a story I've really told ever since I came to Los Angeles County about 4.5 years ago, is everything government does for the most part is location based. We provide services in place. We provide clinics or rec centers or parks or schools or transportation routes and infrastructure. All of these things are located to some kind of an address, a location, a jurisdictional boundary, a supervisor district, or a city, or whatever it may be. And while we may not always obtain our data sets with location in mind, or even think about this in context of how we think about data in decision making, the reality is, even if it wasn't collected that way, we can often link existing data sets to locations to serve our purposes. So anything with a parcel number, an address, a facility name that can be looked up. And again, many of you are familiar with this because you do it in your personal lives when you use your phone to look up the location of a coffee shop or check on traffic status as you're doing your morning commute, or whatever other things you may be looking up by name or category and then navigating to. So everything we do is location based. And what that means in the sense of government operations is almost every data set that exists in government agencies can be linked to a map. There's a few minor exceptions, but most of the time that's true. And what I've found over the last several years working with our many county departments, and especially through the COVID pandemic, is departments and workflows that didn't consider location or maps in the past suddenly had a need for them, suddenly saw an opportunity to leverage maps and resources in the pandemic in ways that they hadn't before. So it's really grown as we've gone through these things. So I'll talk a little bit about a few examples here. Probably one of our most boring but most important categories of geospatial is addressing. And we have an acronym for everything in government. So our addressing system is known as CAMS, the County-Wide Address Management System. And what this is, in essence, is a program that is maintained through our Enterprise GIS that geolocates every address in the county. And there's some very important reasons we need to know that. I would say most importantly is probably emergency services. When you call 911 for police or fire or ambulance types of services, you want to know that the dispatch will know where to find you, where your address is. And that may sound like a fairly straightforward question, but in reality, in a large county like Los Angeles, that's a very complicated problem. I think in the trivia slides at the beginning, we saw Santa Clara County's updating 200 parcels. I don't remember if that was a week or a month. And I don't know how many parcels you have in Santa Clara, but in LA County, we have over 2.4 million parcels. I suspect we're updating more than 200 a day with new ownership, with new subdivisions, with redevelopment, with all kinds of changes that happen at the parcel level as new things happen and things are changing. And more recently, as a way to address some of our housing crunch, that we've had these alternative dwelling units, ADUs, or small houses that people are building in their backyards to create additional living space. Those all need an address. So literally on a daily basis, we're seeing changes and additions to addressing across the county, across these 2.4 million parcels. And the county government is responsible for every one of those, even if they exist in one of our incorporated cities. So we have to have a workflow to learn from cities when they create a new address and add it to the system and then push that back out. So addressing it's, as I said, maybe not the most glamorous and exciting cutting edge thing, but it's very important. So I'm not going to dwell on it too much more other than to say, because of its importance, we've been working over the last year or two on redesigning our entire workflow around addressing to streamline the process for our 88 cities to feed addresses into CAMs. So addresses that maybe used to take a week or two to get from a city to the county and into the official database could transition to being done much more quickly, maybe the same day in most cases. It's an important thing to keep up to date in real time as much as possible. Another obvious place we are using maps and GIS in government is when we're dealing with emergencies like fires. So in this example of the Bobcat fire, which was fairly recent, we had to make decisions on, based on the fire perimeter shown in red on this map, where are we going to evacuate neighborhoods, and when are we going to, as things improve, when are we going to allow people to go back into their neighborhoods? So understanding transportation, population, and the congestion risks on certain roads and routes, where can we, in an orderly fashion, move people out in advance of a risk getting into their neighborhood, and when can we let them back? So in the prior to GIS days, which really is just about 4 years ago when I arrived at the county, all this was done on paper, and all this was posted on websites as, if you live east of such and such a road and north of such and such a road, you should evacuate. So you had to, as a citizen, understand the text, understand where that puts you on the map, and understand what that meant you needed to do, and then move forward. Now we have public facing maps like this that you can very quickly look up an address, see which zone you're in, and see if you're supposed to be evacuating, if you're allowed to come back. Obviously, COVID brought forth a lot of uses for GIS. Here's just a few examples of dashboards and applications we built around helping people to find where they could go for different needs. Some just as simple as recreation. Is a park open? Can I go walk on a trail, or is that facility closed? If I don't have air conditioning in my house, is there somewhere I can get cool? And if I need help with food or other sorts of things, what's going on with different emergency proclamations? So all these different dashboards were spun up during the COVID pandemic. Another important one, very common for us, is location analytics. So looking at walk times or drive times. So in this example, we were interested in looking early in the pandemic at where we have public Wi-Fi in some of our parks and library facilities, how many people can get there within a 15-minute walk. These blobs in color around the central points are 15-minute walk times to a public Wi-Fi site. So a child who needs to get online for school and maybe doesn't have internet access, we could get a sense of where we have it and where we don't, the digital divide. And this version of the map, actually all these gray blobs are showing 15-minute walk times from metro stations. So if somebody isn't within 15 minutes of a site from their neighborhood, could they get on the metro and actually get to a site? And this map showed at the time it was done, not very well. Very few public Wi-Fi sites that would be accessible. And the digital divide is something I'll talk a little bit more about as I go through these slides, because it's a big issue and it continues to be a big part of infrastructure development and federal funding going forward. This map shows the digital divide as it was based on American Community Survey census data, the darker colors being higher lack of internet or higher need. And you can see obviously lots of the communities around Los Angeles, and then some of our rural areas as well are very high need areas. So how do we deal with that? And I'll come back to that in a couple minutes. One way we did try to deal with this early on was to spin up a public Wi-Fi locator. So as I showed in the earlier example, we had knowledge of where all of our libraries, parks, and rec centers and things like that in the county government and city governments had Wi-Fi available. We wanted to fill in some of the gaps a little bit more. So the red and green dots here, we actually pulled from public facing sites, all the McDonald's and Starbucks that had public Wi-Fi. So in this case, we were able to give the public an easy way fairly quickly to put in their address and look up what Wi-Fi is within a selected distance from their location. So in the upper right, they can put an address, they can put a distance here from 1 to 5 miles and say, show me what's nearby. Clicking on these maps then tells you the hours that they're open and available, and some other information to help people find Wi-Fi. It wasn't the best solution, but in the first months of the pandemic, certainly when everyone was scrambling to get online, this was one way we could quickly spin up something to help people. Now, we do have a very large initiative around the digital divide at this point going forward, because we can't expect people to go somewhere to get Wi-Fi and leave their homes. You know, kids doing homework for school, parents doing things from home, you know, for work, for finding public services or applying for jobs. There's so many reasons in this day and age. If you're not online, you're really at a deficit. So we've launched a project that's called Delete the Divide. This is a countywide project that's really targeting getting people online, not just connected, but also educated on what they can do once they're online. So if later you visit this site, you can learn more about it, but I'll give you a little bit of a quick overview. This was launched actually in the last few months with a large school event where we brought in over 3,000 kids and teachers from low-income and disconnected communities around the county to SoFi Stadium and introduced them to the Delete the Divide program. And we've partnered with a number of large corporations and foundations that are offering different opportunities to learn about how technology and the internet's used, not in just coding or GIS, but also in design or automotive or arts or fashion or movies or other industries, so that people can, especially the kids, can see, oh, being online isn't just about becoming a coder. Being online is about opportunity, and a lot of ways we can advance our opportunities through our schools, through our education, and through this program. So we have 85 libraries in the county. We have a very large school population, 80 school districts, 1.4 million students. You can see some of the other stats there. But just to break it down a little bit more, here's what we sort of saw when we started digging into our numbers as we were preparing this program. We have over 365,000 homes with no internet service. And of course, not surprisingly, the majority of these are disproportionately located in low-income neighborhoods and Black and brown communities. We also have a large number of homes that don't even have a device. Cell phones don't count here. We're talking about laptops, Chromebooks, home computers that you could really do more serious work on. And we have over 1 million households that earn less than $50,000 a year. And of course, in California, $50,000 a year is at the fairly low end of you know, a life or you know, a living wage, or you know, especially for a family. So getting an internet connection, buying a computer would not be the first thing you'd think of. And of course, GIS was an important part of this whole project as we were planning and prepping for it. So again, we looked at a number of factors as we did this. We looked at connectivity. This map looks very similar to the one I showed earlier, but this is looking at the percentage of households where nobody can connect at all to the internet on the left, the income in the center map, and then the primary race and ethnicity on the right-hand map. One of the things we find in GIS, and this again shouldn't surprise anybody, is these three maps actually look very similar when you look at the patterns. Low-income homes that are more Black and brown tend to be less connected. And when you look at the wealthier parts of the map, the whiter parts of the map, and the lighter purples or lavenders, those areas tend to be better connected, and they tend to be actually more Caucasian. So these patterns are fairly consistent when we look at this. So as we look at these maps, we can start to target where should we be going first to provide service. And what's happening now and through the next several months to or a year is the County Board of Supervisors in LA has funded the development of publicly provided Wi-Fi service, high-speed wireless internet service to a number of these communities. And we're, as part of our Delete the Divide program, we're going to build out both infrastructure and provide equipment to homes that are signed up in the Delete Divide program, and training for students and small business owners on using their newfound connectivity to improve their opportunities. Now, one last thing I'll talk about on the equity or related is our equity mapping project. So through our equity office of the county, we embarked on a parallel project to really understand in COVID recovery and COVID response how and where we should be focusing resources across the county. This again is a public facing map, and you're welcome to visit all these. We'll provide the links after the presentations. This site allows us to look at a whole bunch of factors related to education, incarceration, health status. There's dozens of layers in here with filters and tools to really target for our county departments. If I want to establish a program for something in the county, where would I best spend my dollars, and where will I best hit the target population I'm trying to serve? So if it's a food program for low-income families, then I might be looking at a different situation than where I'm looking for a jobs program or a new infrastructure build out or something like that. This equity mapping tool we built again at the direction of our equity office, as it's been spun up and used in the county. This is now the tool that is used by our equity office to determine if a project will or will not be funded. So county departments now use this tool to say where they're going to specifically target a program using county resources. And if they don't hit established equity targets that our Board of Supervisors has set, their project will be rejected. If they do show they're hitting the equity goals for the county, the project essentially gets to move forward, can get its funding. So this has become actually a decision-making tool where we're saying, instead of just putting money out across the landscape in some random way, and honestly in the past that may have been, we have 5 soup districts, so we divide our money by 5 and put 1/5 into each of those districts, but maybe not every district has the same needs, so maybe we should think about targeting our resources more productively. So this equity mapping tool gives us a mechanism to inform those decisions and help departments and programs know, are they hitting their targets? And over time, this same tool set and some associated tools will be used to track and monitor programs going forward. And I have to say, shout out to our team. We received a couple of really big awards on this equity mapping tool. We got a Special Achievement in GIS award at Esri this summer, which is the photo, and an Exemplary Systems in Government award from ERISA for the Equity Explorer tool, and also, I believe, a NACO award. So it's been a good year for equity in the county. And all this is hopefully examples that others can learn from and replicate. Okay, and there's a whole bunch more we can do with GIS. I'm not going to keep going through examples, but what I do want to talk about a little bit is, where does the data come from and how some of the emerging technologies come into play. So, as with anything in computing, the answers we can get from this great technology are only as good as the data that we put into them. So there's a number of ways we traditionally collect data. Of course, some is just the typical county business processes where we're receiving information from constituents or permits, or people purchasing a home and filing the paperwork around ownership and assessment. There's all kinds of ways, licensing and so on. So these would be what I'd call our traditional data processes, where data is coming in and getting into a database of some sort. And we might even go door to door, or have community input to some of these things as well, field surveys through organizations like our public works or parks departments. But all these things go into databases, and again, in many cases they have an address, a parcel number, or a lat long that makes them spatial. The emergence of small drones or small unpersoned aerial systems, as we like to call them in the industry, SUAS, has really offered a great opportunity to do site level mapping in a way that's perhaps a little more controlled than when we send somebody out in the field with a notepad and or a tablet and say collect data and write it down and make observations. When we use drones like this, we actually are getting imagery that gives us a permanent record of the state of that site and something we can go back to and leverage going forward in a number of ways. So a number of our county departments are using drones, and I'll just show you a couple examples here. Number one is, again, an emergency response. So this is an example from our Woolsey fire that happened actually about 6 months after I started with the county in 2018, I guess it was. And when you have a fire, there's a lot of things that have to happen. One of them is damage assessment and recovery. So after the fire goes through and it's put out, you have homeowners and business owners who are applying for permits to clean up and rebuild and all sorts of things that have to follow through that process. And traditionally that would be done with door-to-door field work, people going through the neighborhoods or the areas that have burned and assessing the properties to determine what the next steps are. So this was the first time we used drones in a fire response. And the idea here is pretty straightforward. We could fly, in this example I'm showing on the screen, an entire neighborhood that was impacted in about half an hour. Put all those images together. Of course, we get a nice 3D image model of the site, but more importantly, when you zoom in on these images, you can very clearly see if a building is intact, damaged, or destroyed. And you can also see other changes in the environment, like burned vegetation on hillsides that might be a landslide risk in the future when the rain comes, and other factors. So 30 minutes with one or two people out in the field to fly a drone can capture a fairly large area, and you can be looking at that imagery back on the desktop with your assessors or your damage assessment people and your permitting people, and they don't all have to go out in the field, and it doesn't take days or weeks to go through that process. So it's an opportunity to really speed things up. Another place is in code enforcement. So our planning department and others are starting to use drones as a way to do inspections for a variety of different things. And in this example, you can see a drone image on the lower left. That's the point cloud sort of looking at this recycling facility, or basically junkyard. And on the right, you can see a little bit higher view of that from the drone. But what was interesting in this particular example is what happened in the circle on the roof of the building. And it's, I'll tell the story very quickly. A site inspection like this, typically somebody from our planning department would go out, walk the site, make their notes and observations, and decide, is everything in order, or is there something not being handled properly? What's in the circle on the rooftop was not visible walking around this particular site. But what it is it's gas tanks from vehicles that they literally just threw up on top of the roof, so they'd be out of sight, out of mind. And for a long time, nobody would have ever found them. Once we flew a drone on the site, we have photographic evidence of A, that these are there, and B, this is a violation that needs to be addressed. So a very quick flight over a site, and then desktop assessment of the imagery after the fact gives us the opportunity to really understand what's going on and puts our people in a safer situation. They're not having to climb up on roofs or towers. We're not getting into dangerous situations. And again, we get those photo records. Another place that we use imagery more broadly across counties in our LARIAC program, and I'm just going to touch on this for a few slides, because aerial imagery is a very valuable tool. And I saw in this video at the beginning something about looking at vegetation and grass landscaping for the county. One of the things you'll see, maybe if you look at this left-hand image closely, is all the vegetation for the most part is red. That's because this is a false color infrared image. But there is a lawn here that's green. And you might say, well, why is most of this red, but that one's green? Well, very quickly, I could say this red stuff is natural growing vegetation, this green stuff is artificial. So in looking at water use and looking at irrigation and looking at vegetation condition, I could very quickly, without going to the site, see these folks are not irrigating this land, that's artificial. That's pretty useful. We can make measurements as shown here of parcels and buildings and other information from our aerial imagery that's taken across the county. So our LARIAC program has been around for almost 20 years now. We run in 3-year cycles, and this is a collaborative consortium of cities, counties, and other agencies across Los Angeles County, where we fly all 4,000 square miles as a group, and that lets us leverage our resources more efficiently, and then we share all the data and resources from that. I don't know offhand if Santa Clara does something similar, but a number of counties in California have modeled their airphoto programs after LARIAC, and in fact, the LARIAC contract vehicle, if you're a county person, you can piggyback on that and get the same kind of an agreement without having to negotiate your own. So with LARIAC, we derive a whole bunch of products. We get topographic maps, we get building footprints, we get other derived products and LiDAR on certain cycles. So it's a pretty powerful program to give us not just photographs of the county, but these other things. So on this example of Dodger Stadium, you can see the yellow outline is an unchanged structure. The green, such as this, these few small structures are new since the prior LARIAC cycle. So 3 years earlier, those weren't there. We also find out if a building's been modified or replaced in these images with our footprints. And then this example on the right is land cover mapping. So we can start looking at vegetation versus built versus water versus structures and so on. So again, something we can use on our desktops very quickly. And the other thing is we can look at this change assessment. So here's an example of downtown Los Angeles, Grand Park. And I'm just going to go through about 15 years of imagery, and you can sort of watch the change. So you can see the park there and some of the surrounding areas. And then you can see somewhere in the middle here, they tore it all up to redo. And you can also watch some of the surrounding areas here. Then the park's back and has a new fountain. And then as we get into this later time, we can see this parking lot's being built into some new high rises. So using this imagery both gives us this series of time and change, and all of it is mappable and measurable, so we can actually quantify that stuff. Very powerful for assessor, for planning, for permitting, for other operations. One other fire example I want to give you from the Bobcat fire, which was a fairly significant fire, is on the mapping side. There's programs that do disaster imagery, and this is what's called, this is a company called Vexcel. They make this data free to government agencies. So they fly gray sky imagery, which is collected as soon after the event as possible, when there's still smoke in the air, hence gray sky is the name. So here's one of our park facilities near Devil's Punch Bowl that was impacted by the Bobcat fire. And our Parks Department called me up and said, hey, can we get some people to go out and fly drones? We want to do damage assessment of our park facility. I said, we can do better. We already have the data from Vexcel in this program. So this is a before image. This is the after image, and you can see it has the infrared, so vegetation shows up growing in red. And I'll zoom in a little bit. And what you can see here is we can see this building's gone. And it's actually labeled with the little destroyed symbol. This building's intact. We can see the trees that survived and other trees in the area that were burned and other damage. So very quickly, within days of the fire going through and sending nobody to the field, we can get a damage assessment and start preliminary planning for what we're going to do for recovery. In this case, a parks facility, but it could be anything. Okay, so where are we going next? And I'm just going to wrap up with some things that are future directions. That's our theme today, but also these are future directions that are in some cases underway in our county and others. So looking at new types of data, some use of machine learning and artificial intelligence to just make things work better, faster, and in new realms. So one area that's really starting to emerge, and we've done a pilot site for in part of our developed environment, is street level feature extractions. And many of you may be familiar with data like this on your desktops or your phones for mapping and navigation. But this is where we're taking high quality imagery from a street view camera and LiDAR imagery at the same time. And then we can use machine learning to pull out all the important stuff. In the top of this figure, you can see the dots on manhole covers, traffic lights, signs, crosswalk signs. These are all extracted automatically through machine learning and build a GIS database. So again, we don't have to send public works crews out in the field to look at every sign and inventory them. We can build that from driving the streets. We can look at things like ADA ramp condition, slope, and other criteria that say if they meet the regulations for ADA ramps, and so on and so forth. So we had a successful pilot on this. We're actually putting out an RFP later this fall to do this for all 10,000 miles of unincorporated county roads, and maybe even bringing in some of our other city partners to extend it beyond that. This is a huge time savings and a huge savings in the ability to assess condition and need for replacing or repairing something, and just knowing what we have out there on the landscape without driving people, crews out there with notepads. Homelessness is a big issue, of course, in many of our counties. One of the things that we're concerned about, as many are, is when you have a fire or a flood or a mudslide, we know who to evacuate in a neighborhood, but we don't know who may be at risk in these same environments that are in encampments or in tents or in other temporary shelters. So in this example here, we just did a little pilot test to see how well this worked using drone imagery in this case, but this could be our countywide aerial imagery. Looking at a site where you can see there's a lot of stuff going on here. There's structures and tents, and running through some image processing methodologies to do what's essentially called a blob detection to find things that meet the shape, size, color, and so forth that could very likely be a tent or a shelter that somebody's using to live in. So we can get a quick assessment of where we may have hot spots or concentrations of people at risk when a rainstorm's coming in. The river channel, which is what this is, might actually get wet and flood, and we would want to go in and evacuate folks. So there's a lot of ways we're looking at, again, point in time counts, the traditional way of doing homeless population inventory and mapping of who's where, misses a lot because that's done one day in the year and primarily, in locations where it's easy to see the tents or the shelters. When people are set up in the trees or bushes, you can easily miss them. And speaking of trees, another big initiative, and the last one I'll talk about, is mapping our trees. So governments have a lot of trees we care about. We know we have street trees, we have park trees and other public facilities, and we're pretty good at inventorying those because those are managed by our public works or parks departments. But we don't know much about private trees in business parks, university campuses, backyards, and other areas that are not part of the government jurisdiction explicitly. But when we're looking at things like fire risk, fuels, insect damage, and so on, those impact trees regardless of who manages and owns them. So we want to know about fuels or dead and dying trees, regardless of if it's a street tree, a park tree, or a privately owned tree. So again, using imagery, remote sensing methods, we are exploring ways to build out a countywide map of trees through remote sensing. And this, I'm just going to talk through this very quickly. I'll shout out UCLA and Colorado Boulder, our partners on this project. We're using imagery from our LARIAC program, LiDAR, laser imagery from our LARIAC program, and hyperspectral imagery from NASA, which is what this thing is. It's a 225 band image, which may mean nothing to many of you, but it's very detailed multispectral imagery, many colors of the rainbow, so to speak. And looking if we can pull out trees, not just that it's a tree, but its condition, maybe it's species and size as well, more structural and health information. The preliminary work on this is actually going very positively. We're getting accuracy similar to what you would get by a field visit. So that's exciting. We'll see how this goes. But the upside is, while we could do a tree inventory of public trees maybe about once a decade because of the number and time of trees and the time it takes, this could do the whole run in a matter of maybe a couple of weeks of compute time using machine learning and AI. So I'm going to wrap up with just a few closing comments. Obviously, governments use imagery, GIS, mapping, and so on in a lot of ways. I think machine learning and AI are really a lot of the future direction that we're exploring to automate and make replicable many of these processes for all these different bullets I've got on the screen. And I think the other thing that's been interesting is work from home because of the COVID pandemic really raised the profile of geospatial, because we didn't miss a beat as GIS people. We can work, we're used to working in cloud environments. We're used to working online. We can be anywhere with our computer and internet connection and do all of this work, desktop assessments, do the mapping, do the predictive models and so on. So it really raised the profile and value of geospatial within new applications across the county. And I think that's really valuable. We also put a lot of stuff out to the public, as I alluded to, and I'm going to shout out Santa Clara here and say, governments have lots of data you can use, and a lot of it's easily accessed through open data portals such as Santa Clara County, LA County, and others have. So check this stuff out. There's applications you can use through your web browser. There's also data sets, if you are a GIS person, you can access and use in your own analysis. So to kind of wrap this up, it's not really, in my mind, about the technology itself. Yes, computers, GIS, imagery, and all this is really fun, but it's really about what can we do with the data? How can we use analytics to inform decision-making in government, to put resources where they're most needed, to better target risks and opportunities, whether those are natural risks like fires and floods, or whether those are risks of pandemics or just poverty and not being connected to the internet. There's a lot of opportunities that we can improve our speed and timeliness and accuracy of our assessments to give our decision makers information that'll really help them to do a better job as they do this stuff. We can also get rid of a lot of the human error. When you send people out in the field, two different people may give you two different answers visiting the same site and making observations. Machine learning can get us to something more consistent and repeatable. And as I think all of you probably recognize, maps are great communication tools back out to the decision makers, to the public, and to the end users. So I think there's a lot of places we can continue to grow and expand that. So I would be remiss not to mention I have a couple of co-authored books I'll mention if you want to learn more about using GIS or how GIS is used in resilience across different communities. These are a couple of books you might want to check out. And then my last comment is GIS Day for Santa Clara County is today, but officially GIS Day globally is in 2 weeks on November 16th. And since you're going to be done with Santa Clara County, I invite you to join us for LA County's 15th annual GIS Day on November 16th. And if you visit our county website, gis.lacounty.gov, and click on that GIS Day link, you can do the free registration and check out our agenda there. And with that, I will thank you all for listening to me, and I know I went right up to the top of the hour, so I'm happy to stay in the break and answer questions or do so in writing afterwards. But thank you all.
Thank you very much, Dr. Steven Steinberg. All right, so I guess let's take a couple of minutes just getting into the break time, but we have a few questions. So the first question, how about the transit travel time? I guess this question is related with when you are showing the map of the access to the metro station. Mm-hmm. So how about the transit travel time?
Yeah, so those are fairly standard geospatial tools in our GIS platforms. They look at, depending if you do walk or drive time, where somebody could travel from point A to point B. And they do actually account for historic traffic as well. So you can say, if I wanted to travel from A to B at 5 o'clock on a Thursday, you know, where can I get in 15 minutes? You know, or if I'm walking, it's obviously looking at things like, well, I have to go on an overpass. I can't just cross the highway anywhere. So those travel time algorithms are right out of the box in most GIS software, but they're very valuable because we don't always think about, especially in social services types of situations. You know, we open a clinic somewhere or a social service office somewhere, and then, you know, somebody has to go to that one, and then they have to go to one somewhere else for a different service they need. And when you're thinking about people who may not have personal transportation and they have to go on metro lines, you know, making sure we put things in accessible places, we cluster them so they're not opposite sides of the county, is really important. So we've really been using that in the examples I showed, but also to look at for a whole bunch of our social services and sort of clinics and other things, can we start to cluster things more and make things more accessible to people who don't have vehicles and need to do 2 or 3 things in the same day and don't want to take the whole day to do it?
Great, thank you. There is 2 questions related with your feature extraction. I will just 2 questions at the same time. So is the street level feature extraction done by consultant, and why done only in unincorporated areas?
Sure. So yeah, so the pilot study we did was done through a vendor as a case study we did a couple of years ago. Now we're going to put out a bid to get a vendor to do the entire unincorporated county. And the reason it's unincorporated is really just jurisdictions and budgets. Our public works department is willing to pay for the 10,000 miles of unincorporated. And if any of the city governments want to piggyback on that, obviously they're welcome to. We wrote the RFP to allow for that to happen at the same time, but we can't pay for all the 88 cities streets to be driven. And then the vendor does have algorithms, machine learning, that run a lot of the standard extractions out of the box. The stuff we're doing on ADA ramps is a custom extraction where we worked with them on to meet our specs.
Great, thank you. There's another question related with the street level extraction. Where is the source of the street view images?
So these images are actually collected by the vendors that do this kind of work. And you know, they look like Google Street View. I'd call them Google Street View on steroids. The cameras that are driven are much higher resolution, to the point where if I'm looking straight up at a street light, I can read the wattage tag on the street light from the image. They're like sub-centimeter resolution. I think it's like a crazy 250 megapixel camera or something like that in the 360 hemisphere. They also, though, don't just do imagery, they do LiDAR. So you get a full 3D model of everything. So everything can be measured, heights, distances, areas. So it's a custom system. There's a number of vendors. I'm not going to shout out any particular vendor here, but there's a number of vendors that do this sort of stuff.
Okay, great. Okay, 2 more questions I would like to, and then I would like to wrap it up.
Sure.
And one question, you mentioned machine learning and an AI tool that make your job easier. Do you really need a computer science background in order to know how to utilize them?
Not necessarily. So again, some of these are out of the box through vendors, so we're not developing them in-house. Others we're kind of developing in-house. So the example I gave on the blob detection of tents in the homeless example, and the example of the tree classifications I gave, the last 2, those we're actually doing in partnership with universities. So again, we as county employees don't have to have the computer science backgrounds, but the students working on this and the faculty working on this with us, by all means, do. They're developing the code and the machine learning algorithms to do the feature extraction. So somebody out there does need to do that, and it's an open question in my mind whether we really need that internal in our own staff, because it's an occasional thing. You have a new machine learning algorithm and then you're done. But we are doing one I didn't talk about internally as well, where I have actually a couple of staff on our enterprise team are doing a machine learning algorithm on finding cooling towers on building rooftops for public health. So remains to be seen, but I think, yes, having that background is certainly helpful. in the industry side and a bit in the county side too.
Thank you. Last question. How do you decide what outside data is valid enough to be integrated into your maps?
It's a great question. So if it's contracted through a vendor, we write that into the specs. So we actually define how good the data has to be accepted. So for our air photo program, for our street imagery program that we're gonna, and these other RFPs we do to get contractors on board, we do determine that. Usually we're following some kind of a standard. So like for aerial photography, we're following standards that are put out by the Professional Association for Aerial Imaging and LiDAR. So sometimes they're industry standards or professional standards or survey standards. If it's truly public contributed data, we do have to, do some kind of a QA/QC. So in our CAMS program, the best example I can think of right now, a city may give us address updates. We have automated quality checkers that validate and check all the formatting and structure and locations of things to make sure they make sense. And if not, it kicks it back to the contributor and says, hey, you need to look at this. It doesn't seem to be right, or it's not formatted properly. So there are a whole bunch of other tools and technologies we use to automate QA/QC and rank how good things are. But at the end of the day, yes, we're responsible. We have to vet the data.
Great. Thank you very much. I know there are several other questions that we just don't have time to answer all, but we will forward the questions for you. And for those folks, your questions were not answered today, please just type them in, even though you can't get an answer today. We will compile it and then put it on our website. Thank you very much, Dr. Steinberg.
Thank you. And I appreciate you all hanging in. You got 2-minute break left.
Yes. Okay.
And
so
good to see some familiar names in the participants. So hi to all you I know.
Thank you very much.
All right. Take care, everyone.